Superposition and interference of waves. Before I start the actual lesson, I'd like to review what a sound wave is. Sound waves are created by compressing and expanding air, creating high pressures and low pressures. And a full wavelength, or lambda, is considered from here to here. Alright, interference is more or less sound waves stacking on top of one another. There are two types of interference, constructive and destructive. Constructive interference occurs when sound waves basically line up perfectly, like so. The way I was taught constructive interference was to pretend that all the bumps and dips are mounds of dirt and holes. So since you have a mound of dirt on top of another mound of dirt, you basically have a giant mound of dirt. And since you have a hole inside of a hole, which is a bit hard to understand, you have a really big hole. Now, because you have a really big hill and you have a really big hole, that causes very big amplitudes in your sound waves. And big amplitudes result in louder sounds. Destructive interference is a bit harder to understand. Mathematically, destructive interference occurs when the second sound wave is 1/2 lambda behind the first sound wave. So what does that mean exactly? Well, we know lambda is from here to here. So 1/2 lambda is here. So if I want to create destructive interference, I would have to take this hole and move it back 1/2 lambda. And I would have to take this hill and also move it back 1/2 lambda. Now let me clear this up so we can see everything a bit easier. So since we have a hill and a hole and another hill and a hole, you fill the hole with a mound of dirt, causing flat land. And then you fill the second hill with another mound of dirt, causing flat land. So since the whole thing's flatlining, that means there's no sound, hence destructive interference. In our next lesson, we'll see a video demo of how it looks like from a bird's eye view.